Okay, good morning, good afternoon and good evening to everybody of you around the globe, wherever you are. I wish you warmly welcome to the Kalmar webcast about the automated straddle carriers today, and I'm very happy to announce you guys that we have almost 200 people joining around the globe, so that is excellent thing that we have so many people interested about this remarkable technology. My name is Timo Alho, and I am the Director for the Terminal Automation within Kalmar, based in Finland, Tampere. So just to paint the big picture before we start to go, I'm presenting here that we at Kalmar are developing and providing different technologies to different terminals, different environments, depending on the way how the terminals operate. There are technologies to automate the straddle carriers, automate RTGs, automatic stacking cranes, and then hybrid terminals, which really means that we can provide a mix of different technologies, including the horizontal transportation and automated stacking cranes. There are also different technologies that actually are used to implement these terminals. But now, today, we are really concentrating on the fully automated straddle carriers in the way that we have been developing and implementing them in the Australia cases at Patrick's terminals, which are Fisherman Islands in Brisbane and Port Botany in Sydney. But without going into any further details, I will hand over this now to Michael Hickson in Australia, who will lead you through the presentation. Thank you from my behalf.
Hello, thank you, Timo. My name's Michael Hickson, and I'm the Business Development Manager for Kalmar's Horizontal Transport Automation Group. I've had the good fortune of being involved in the AutoStrad technology for a number of years. I've got an engineering background, but don't hold that against me. My main areas of responsibility now are product management and global sales support for the AutoStrad product. But I'm not alone. With me are a team of experts. So that, and the idea of this webinar is that if you have any questions at all, please type them in and our team of experts will attempt to answer them. I apologize in advance. We've got a very big audience, as Timo has suggested, so there is a possibility that we may not get to every single question. Some housekeeping. So this webinar and the videos shown will be put onto YouTube on the Kalmar YouTube channel, and I encourage you all to have a look at that YouTube channel because there's a number of other interesting videos that no doubt you'll find of use and of value. Let's begin. So in terms of what we'll cover today, I aim to talk for about 30 to 40 minutes, and then we'll have a good 20 minutes or so of Q&A at the end, where again I invite you to ask a question and our experts will attempt to answer them. I'll begin by giving a brief introduction to the AutoStrad, some of the key onboard automation technologies. This will be followed by a brief history of the project, of the AutoStrad project, and of Fisherman Island in particular. We look at some of the design and operations of Fisherman Island, and this will be followed by some of the features and functions that have been built into the technology that have gone to make this such a success. The fifth thing we'll do is look at some of the achievements, in particular the financial achievements of the AutoStrad product, which I'm sure you'll find of interest and may be of use in building the business case for supporting AutoStrad deployment. I'll briefly touch on the future of the future projects, and then we'll move on to the Q&A the Q&A section of the webinar, as I mentioned. Let's begin. So the basics. What we're talking about here is an automated self-loading container carrier. There are two variants of the AutoStrad, the 1/2 or 3 high automated straddle carrier and the 1/3 or 4 high. In Fisherman Island and in Port Botany, what's being implemented is the 3 high, that is the 1/2 AutoStrad. As any straddle carrier terminal would know, one of the key benefits of a piece of machinery like this is the flexibility. It's a single mode of operation. You can handle the ship-to-shore crane interface, the shuffling and the decking in the yard, and any hinterland or interfaces with any other types of equipment. A lot of attention and investment's been put into the production control to make it as simple to use as possible. And the AutoStrad real-time control system, fleet management system, interfaces directly to a TOS. Optimization is obviously critical to the success of the automation of the AutoStrad solution, and we have an integrated optimization across all modules. Safety is of course critical as well, and it's built intrinsically into the AutoStrad system. Lastly, the AutoStrad is great for business. It's an efficient use of CapEx. It's very competitive cost of production, as we will see some of the figures later on, and it's flexible for future growth. The upfront cost of an AutoStrad solution is comparatively less compared to other types of automated equipment. And the benefit is that it can scale up as your terminal volumes scale up. Importantly too, this technology is ready for greenfield and brownfield projects. I'd just like to talk briefly about some of the onboard automation features and some of the key technologies involved. Just give you a few seconds to just take in this slide, which is basically a graphic that represents some of the various different onboard subsystems. I won't go through them all. I'll invite you to do that in your own time if you view the webinar on YouTube. I'll just point out a few of the key features. Firstly, point number one, the radar. The radar is the primary navigation sensor on the AutoStrad. It functions by measuring range and orientation to completely passive beacons that are mounted around the perimeter of the AutoStrad container terminal. It's important to note that no GPS is used on the AutoStrad. GPS for control of an automated vehicle is simply not reliable enough. In the container port environment, there's further problems with multipathing from the high numbers of reflections of containers and the occlusions that ship-to-shore cranes and container vessels themselves. The result is that they block GPS satellites to such an extent that GPS becomes almost unusable around the ship-to-shore cranes. As a result, no GPS is used on the AutoStrad. Navigation is done through the radar, through the IMU, and through the encoders. The AutoStrad uses a full extended Kalmar filter navigation system that fuses the information from all of those above mentioned sensors to produce a navigation position. The other thing I'll just draw to your attention in terms of the vehicle technologies is the obstacle detection sensors. These are lasers mounted on all four corners of the straddle leg. They are used to detect exceptions and bring the vehicle to a safe stop. They also serve for another purpose. We use the laser information for advanced box docking functionalities that enables the AutoStrad to stack 1, 2, 3 high containers with a high degree of accuracy. The second and third tier containers are lined up perfectly with the first tier container to make sure that we have nice, smooth, continuous container stacks. A brief history of the AutoStrad project. The genesis of this project goes back to 1996, and it was really the coming together of three parties: Patrick Stevedores, the University of Sydney's Field Robotics Department, and Kalmar. It wasn't really until 2001 that the project began to take shape, when Patrick acquired a small parcel of land in Brisbane along with some equipment. A demonstrator fleet of 5 manual machines, which was taken from Patrick's Port Botany terminal and retrofitted to become automated machines, was implemented into Brisbane, and that proved the concept. Patrick decided to go ahead and they purchased 14 brand new Gen 6 cabinless machines, the first cabinless machines in the world, and the Patrick Fisherman Island began its commercial operations in 2005. As the technology matured and as the container trade in Brisbane grew, the AutoStrad system took all of Patrick's Brisbane trade It scaled up by adding more machines over the years in 2007 and 2010, till finally we got to our current fleet size in Brisbane of 27 AutoStrads and a 3-berth operation. The other key points to note in terms of the timeline, in 2012 the Port Botany automation contract was awarded to Kalmar, which sees Kalmar being awarded key responsibilities in delivering machines and automated software to the Port Botany project. This project involves 44 vehicles to Port Botany. Also in 2012, Kalmar acquires all the AutoStrad technology that was previously developed by Patrick. Just wanted to give some sort of context for Fisherman Island so people understand what it is we're dealing with and how the terminal is laid out. This picture here gives you an almost a plan view of the terminal. I'd just like to highlight a few key points. So firstly, the quay line. It's a 3-berth operation, as I said, and 930 metres of quay line in Brisbane. The operation is done through the back reach. There's a 2-lane back reach for the 4 quay cranes. All the lids and twist lock operations, as well as the waterside workers, all that operational stuff is done between the legs or underneath the portal of the cranes. As you'll see later, there is a fence, a perimeter fence that separates all the automated machines from any human beings. This is a principle of the safety of operation, that the automated machines maintain a strict separation between the machines and any human operators. The yard itself, there's 5,000 odd ground slots in Brisbane, giving a maximum capacity of approximately 800,000 TEU. Current throughput through Brisbane is approximately 500,000 TEU per annum. The AutoStrad stack up to 3 high in the yard. A complete random stacking strategy is used, and the AutoStrad real-time control system manages all the logistics and scheduling decisions. Brisbane is an exporter of a large exporter of fresh fruit and meat, and as a result, Brisbane Container Terminal has a large number of refrigerated cargo or reefer areas. What's highlighted here are the purpose-built reefer exchange blocks, where the AutoStrads can place their containers in the reefer blocks. There's a gate system, a dual locking gate system that allows the reefer care operators to come in and to plug in the containers while maintaining this separation from machines and people. On the hinterland, there's 28 truck grids. It's an import-export terminal, only a small amount of transshipment containers in Brisbane. I'll go into more details about how the truck grids function and their design. Down to the bottom of the right screen is the maintenance area and the transfer area in which machines are moved in and out of the automation yard in a safe way, always maintaining that separation between people and machines that I spoke about. Lastly, there's a reach stacker straddle interchange zone, which allows Patrick to run in bulk runs of empty containers to service some clients. Just a little bit about the infrastructure involved in the AutoStrad yard and some of the differences between a conventional straddle carrier and an AutoStrad. Firstly, there's no line or slot markings in the AutoStrad yard, apart from one exception. At the crane lanes in Brisbane, we have manually driven cranes, of course. There are 2 sets of parallel lines for the 2 crane lane exchanges. The ship-to-shore crane on ship discharge, the driver places the container in between those lines and the straddle carrier comes along, picks it up and deposits that box in the yard. Because there's no lines or slot markings, we've developed a neat feature called the stack shuttle, which effectively allows the straddles to incrementally move both the container stacks and all the roadways, effectively spreading the straddle carrier and container load throughout the terminal. Some civil engineering device that we've got for Brisbane has suggested that the pavement life in Brisbane will be extended by double because of this feature. Interestingly enough too, the Brisbane Container Terminal uses interlocking, for the most part of the Brisbane Container Terminal at Fisherman Island, interlocking pavers are used. Some areas do use concrete, but the bulk of the terminal uses interlocking pavers, which are a far cheaper way to pave and build a container terminal. No perpendicular roadways are needed. Every row in every block is a roadway. The AutoStrad does not distinguish between them. Of course, as with any straddle carrier terminal, there's no constraints in terms of the layout. It's flexible for any sort of irregular shape, size and shape terminal. As mentioned, there's a perimeter fencing and an isolation process for maintenance and remediation, all the time maintaining that separation between humans and machines. In terms of other types of infrastructure in communications, navigation and CCTV, communication between the AutoStrads and the real-time control system is done through wireless LAN. Wireless LAN access points are mounted on the light towers throughout the Fisherman Island container terminal. Incidentally, the AutoStrads, of course, do not need the light towers to see what they're doing. However, in Australia anyway, container ports have deemed a high security area and lighting is required to provide the security needs. The navigation system, as I've mentioned, is based on radar, millimeter wave radar. It's a completely closed system. It requires no external satellites or any other external sensors. The way it works is that we put a constellation of beacons at approximately 12.5 meters above the ground, which is the height required for a 3-high AutoStrad. Obviously for a 4-high AutoStrad, they need to be a little higher, approximately 15.5 meters. Once the beacon is installed, and by the way, it's a completely passive reflector, effectively just a piece of folded sheet metal. Once it's installed, it requires no power, it requires no maintenance after its installation and commissioning. The straddle triangulates its position by measuring the range and orientation to these beacons. CCTV is used throughout the terminal as well for operational and exception handling needs. A few slides here on how the truck handling works. So the truck grids in Brisbane are angled at this 45-degree orientation. In Brisbane, the maximum length of truck is what they call a super BW, which is effectively 4 TEUs, or almost a 40-meter long truck. So the truck grids themselves are around 40 meters. They're built to handle this type of large truck. Each truck grid consists of 2 sets of gates, a straddle side gate and the street side gate. Only one set of gates can be open at any particular point in time. When the truck enters, as in this example here, the straddle gates are closed, the truck gates are open, the truck reverses in, and then the gates reverse. So the street side gates close, the straddle side gates open, the straddle comes in and services the truck. Important point to know that all export jobs, so all the picks from trucks, are done completely automatically. There's no need for a human operator at all. The landing of containers onto trucks requires what we call a teleop operator, effectively a staff member on the ground with a pennant to do the last 2% of the job, that is the placement of the container onto the truck chassis, lining up the twist locks. I'd now like to show you some of the crane productivity features and the neat features that we've developed that help deliver the great crane productivity that we see in the AutoStrad in Fisherman Island. The first one I want to show you is the twin forming feature. We've got a small video here that will demonstrate this. I'll just invite my colleague to load up our video. And it may be the case that this video may not appear smoothly to some viewers. If not, it will be available on YouTube. I'd just like you to observe the middle crane in this example. So what we're doing here is doing the twin forming. So there's a 20-foot container on the ground. The straddle carrier has come and placed a second 20-foot container right next to the one on the ground. It uses its lasers, highly accurate lasers and navigation system to perfectly align the containers, and then the ship-to-shore crane picks the two up as a pair. This is obviously a great way to maintain crane productivity, because effectively the crane is moving 2 boxes for every load. In this example, the straddle has tried to form the twin, it's detected an error in the side shift system, and it's self-corrected. Importantly, no frames or any other external sensors are used. That particular feature utilizes the existing lasers and the existing navigation system and the self-calibrating side shift. The next feature I'd like to talk about is the dual cycling. The way dual cycling works is that we'll begin the sequence by discharging one entire cell from a ship. What happens next is that a load box is delivered into the empty cell by the ship-to-shore crane. On the way out, the ship-to-shore crane discharges a container to the AutoStrads in the back reach. Step 4, the ship-to-shore crane then picks up another load box from the AutoStrads, delivers it into the cell, and then on its way out again, discharges another box. So effectively, every move to and from the ship sees the ship-to-shore crane carrying a full box. So in the case of normally doing 30 moves per hour, utilizing dual cycling, we can do 60 moves per hour. I'd just like to show another video that demonstrates this in action. And to add some further complexity to this, so what we're doing in this example is we're discharging twins and backloading a 40-footer. So a few things to note in this video. Please note the fence that separates the people, the operators, the waterside workers from the AutoStrads. You'll also note too how the twist locks are done between the legs. So the ship-to-shore crane will do this kind of double hop movement, bringing the container between the legs of the portal for the operator to remove the twist locks, and then bringing the container over the beam into the back reach of the crane for the straddles to service. Dual cycling works particularly well for a straddle carrier terminal because it utilizes the inherent decoupling involved with a straddle or shuttle solution. This enables the system to respond to any exceptions, faults or shocks without losing the rhythm or the sequence of the dual cycling procedure. So how is all this possible? I'd just like to talk a little bit about the AutoStrad real-time control system that's been developed in Australia and implemented in Brisbane and will be implemented in Port Botany. So it's got a very layered approach to its architecture. I could just draw your attention to the triangle on the right. The top of the triangle is the typical functions that the terminal operating system will do. The EDI, the reporting, ship berthing, ship planning, etc. The orange and the blue sections are the AutoStrad real-time control system, and it effectively works with 2 layers. We have the logistics layer, which is responsible for the decking solution and all decking and scheduling. So making decisions about which straddle moves a container, where it's placed, and when. The transport layer has effectively the responsibility of doing the traffic path planning, routing, fault management, and so on. This also has the role of avoiding deadlocks and managing any sort of exceptions that may happen. Important to note that optimization works across all the modules in a coherent fashion. There's a few other points there on the left that I won't go through too much. The only one I'd like to draw your attention to is the bottom point, which is about the pooling. So there are no dedicated points of work. There's no straddles dedicated to a particular point of work in Brisbane. The equipment is pooled right across the terminal, so that any particular straddle at any particular point in time could be doing a crane job, followed by a yard job, followed by a road job, and so on. So why automate? What are really the business cases, the drivers for automation for the AutoStrad? I think they've been probably talked about in quite a few settings in TOC and various places around the world. So I won't go into detail for all of these particular reasons. The ones that speak strongly to me are really the second one, the safety of personnel, cargo and equipment, and we'll talk a little bit more about the safety in subsequent slides, but this to me is one of the key reasons to automate. It makes the environment a much safer, a much happier, a much cleaner place to work. And probably the last one, reducing the unit cost of production. The AutoStrad, as we've seen, as has been realised in Brisbane, dramatically reduces the unit cost of production for a container terminal. In terms of building the business case, one of the perhaps the more overlooked things to consider is the amount of space required between the crane legs and the beginning of a stack. In Brisbane, this distance is 47 metres, which compared to other types of automated horizontal transport is much smaller. So in Brisbane we have, as I've indicated previously, 2-lane back reach operations, so the interchange between the ship-to-shore crane and the straddles is through these 2 lanes here. Then we have 3 lanes of highways. Container stacks start here, and as mentioned, 47 metres. In terms of manning in Brisbane, first thing to note, crane gangs, 4-man crane gangs. So Brisbane has 2 crane drivers. This 4-man crane gang consists effectively of 2 crane drivers, so each crane driver working 50% of the shift. 1 foreman, whose job predominantly is just to be on deck on the vessel and manage the operation, and 1 work where required. So typically the method of operation is that we have 1 crane driver in the crane, the second crane driver and the work where required, or WWR, does the twist lock operations in the portal. In terms of the land side, we have 2 teleoperators and 1 yard team leader. So 3 guys that manage the whole truck interchange. And just to give you some context on what type of volumes can be handled, so typically in Brisbane over an 8-hour shift, you have 1,000 containers coming through the truck grids, and these 3 operators are more than capable enough to deliver volumes of that sort of magnitude. 1 tower clerk, 1 gate clerk, 2 reefer guys. Total of 19 people for a 500,000 TEU terminal. 19 people for that particular shift, exclusive of the lashes. A little bit about safety. And we've got here a quote from John Mullen, the head of Asiano on this particular issue. In the first year of automation at our Brisbane AutoStrad terminal, we achieved a 75% reduction in safety incidents, increasing to a reduction of 90% in following years. It is only logical that we look to replicate this success at our biggest container terminal at Port Botany. The LTIFR, the lost time injury frequency rate, has almost gone through the floor. This is effectively the frequency of lost time injuries, which is defined as as either a death, a disability, or a loss of a single working day or a single working shift. Now we're going to see another video from Matt Hollenby, who is the terminal manager of Brisbane Container Terminal.
The Patrick Brisbane AutoStrad terminal is very important to this company as it showcases the automated technology that we've developed in Australia, and it's our principal source of competitive advantage in an increasingly competitive market. Patrick pioneered automation in this country. Indeed, when the Brisbane AutoStrad terminal was first opened in 2005, it was one of only 3 automated terminals in the world. We've used Kalmar machinery in a manual sense for many, many years. Kalmar were the leading manufacturer of straddle carriers at that point in time, and so it was a natural alliance for us. Patrick had developed the automated technology. Kalmar had a quality machine into which it could be installed. There are the obvious benefits that flow from automation, reducing the cost of production. But there are other significant and very important benefits. For instance, our lost time injuries in this terminal are next to nothing. We've gone a year without a lost time injury. It's a very safe environment, which to Patrick is a very important outcome. Additionally, there are a whole range of ancillary savings related to infrastructure and maintenance. Our maintenance costs have reduced as a consequence of machines going into an idle mode, therefore reducing the number of engine hours and thus the time between services, or extending the time between services. The straddle carriers don't need to see at night, so as a consequence we can turn the lights off after dark in various parts of the terminal and save electricity. Pavement wear and tear, across a whole range of features, damage to cargo, equipment and what have you. All of these metrics are positive in an automated environment. We believe that the AutoStrad offers significant benefits over and above other forms of automated equipment, principally AGVs. Those benefits are related to the flexibility of the system. Without being disrespectful, in an AGV environment, the crane driver is obliged to discharge the container onto a waiting AGV. We maintain that the coupling of the AGV to the ship-to-shore gantry crane is a potential source of weakness. A strength of our system, conversely, is the fact that the crane driver can discharge the box to the tarmac and we can build a buffer stack behind the crane. We would argue that the automated straddle carrier is far more flexible, scalable and deployable than traditional AGV technology. Our customers increasingly require consistency of service. Automation delivers consistency of service, it smooths out peaks and troughs, it allows our customers to proceed with certainty in terms of their scheduling.
Schedule integrity is critical to our customers' business. Automation and the consistent productivity that it brings allows us to meet our customers' needs.
As fleets reach their use-by date, I think that's the critical point at which people should look at automation, but look at it across a whole range of areas, what it could do for completely changing the container terminal. This is not simply about moving a box from point A to point B. Automation changes the whole way that the container terminal is managed.
Okay, apologies to anyone who had trouble with that video streaming through. I hope that all of it worked for most of you. Again, if there was anyone that didn't perhaps see it, it will be made available on our Kalmar YouTube channel after the conclusion of this webinar. Little on the value for terminal operators, and this is the value that's really been realised at Fisherman Island and will be realised at Port Botany for Patrick. The performance, I guess, is undeniable, and the results really speak for itself in terms of the value. First point, labour cost per lift saving of 30 to 40 Australian dollars per container compared to Patrick's non-automated straddle ports. So just for everyone's interest, Patrick has 3 East Coast ports in Australia. They're all 3 high straddle ports. Brisbane is the only one that's automated. Sydney will be automated next year, and Melbourne is a manual port. So we've got pretty good comparison between the manual machines and the automated machines in a single context. So we see very good savings there. The workers' compensation costs over 90% lower compared to Patrick's non-automated straddle ports, all while handling increased volumes and maintaining the 98% vessel departure performance. Brisbane is Australia's fastest growing container terminal, and for the 10 years up until 2009, growth in Brisbane's trade was almost 11% per annum. Patrick themselves, the 4th point on the left, have estimated that they will save $50 million per annum with the introduction of AutoStrads into Port Botany Terminal. The coordinated fleet management and optimization, this point here I'm onto now. So this has seen the AutoStrad system deliver gross average crane rates in excess of 30 moves per hour. It's an important point, and when you talk about crane rates, people always ask, how do you calculate that? So in Brisbane, just so everyone's clear, what we see is the standard shift is 8 hours. There is a 45-minute smoker or 45-minute lunch break, which the union guy, the operators do not work in that time. So the actual working time is a little over 7 hours. Regardless, over that 8-hour shift, 240 moves are typically done by the STS crane. So depending on how you calculate it, if you want to calculate it divided by 8, by the gross crane rate, it's 30 moves per hour. If you want to just calculate it by dividing by the working time, you're looking at 33, 34 moves per hour. Maintenance savings through the more efficient machine use, more than $500,000 over the lifetime of the machine. Interesting point that the automated machines are actually cheaper to maintain than the manual machines, largely because the maintenance is more predictable. There's less in the way of collisions, as Matt said in that video, and less what they call nuisance maintenance. And the last point I'd raise is the safety. Patrick, Brisbane, over a year without lost time to injury, and that has benefits in all sorts of ways. Most of these figures I point to you are actually publicly available on the Asiano website, and there's a few links there that I invite you to have a look at if you feel so inclined. The future, some important points here. Kalmar owns the technology needed to deploy the AutoStrad solution from when Kalmar acquired this in 2012. Kalmar has the people that have the depth of experience in container terminal operations. for successful deployment of the system. Kalmar is providing the key technologies for the automation of Port Botany container terminal. Why did Asciano choose the AutoStrad solution? It's a proven solution, it's safe, it's productive, scalable, flexible and deployable. And as John Mullen, the Asciano chief, said, this is a critical part of the growth strategy for the company's long-term future and competitiveness in an environment where a third stevedore is imminent. And indeed, actually, the third stevedore is here and soon to be in all 3 container ports. Reasons why would you automate? And this really comes back to that theme. It's about the ease of automation. This is a modular solution. It's got fast deployment, relatively low upfront cost compared to other types of automation. It's a fundamental process change with lower complexity due to the single type of equipment. We've talked about the productivity, efficiency and safety in the solution, the low incremental cost of automation, the low unit cost of production, and the financial measures that you'll see that you've seen and that you'll see on the Asciano website sort of speak for themselves: the return on assets, labour to revenue ratio, gross margins. And lastly, this is a solution that's compatible with growth, that your terminal and your investment can scale up as the volumes in your terminal increase. This really concludes the speaking part of the presentation. There's a few contacts here for if you have any further questions that are not answered. My details are down the bottom here. So feel free to email me or any of my colleagues who, about this technology or any other further questions that you may have. And now we'll go to the Q&A part of the presentation, of the webinar. So I see there's quite a few questions already coming in, and I hope my colleagues have been able to answer those to everyone's content. So my technical colleague will now switch to the Q&A view. And so I invite you to put your questions forward. My colleagues from around the world will take it in turns and divide up the questions and answer them as they see fit. I will also do my best to answer any questions that come through. No questions just yet. I see there are a lot of questions still coming through in the chat. We've got a question from Pekka Ranta. So do you have CapEx and OpEx comparison between different types of automation solutions, including infrastructure, equipment, labor, and IT cost? Yes, that's a good question. We do have that information. So for the purposes of this presentation, we have not got a slide that shows that, unfortunately. But this particular question has been studied I think quite a number of times in different formats, different places of the world. The automation conference and webinars and TOC. Just refer to, maybe that's probably something that we can dig up some more information that we can probably share with Pekka offline on that particular one. So question from Carlos in Uruguay about reefer containers plugged into the automated terminal. Andrew is answering that one. So we have an airlock system. It works in the same way. The straddles place the containers in the dedicated reefer bays. There are a series of gates that close and that basically prevent straddles from coming into a reefer bay, and then the reefer operators go in through dedicated gates to then plug the reefers in. Daniel's asked, do we need to install something in the ground for the straddle carrier to operate, the AutoStrad to operate? The answer is no, nothing is installed into the ground in the AutoStrad system. It can run on asphalt, it can run on pavers, it can run on concrete. The navigation is done through the radar, through the beacons are at the 12.5 meters above the ground, through the radar, the IMU and the encoders and the onboard processor, which fuses all that information into through an extended Kalmar filter to produce a navigation solution. A question on the stack shuffle or the lane shuffle feature. What is the range of adjustment? So the amplitude, I suppose, is unlimited. What limits the amplitude of the adjustment is the physical infrastructure that surrounds a container stack. So in Brisbane we have a 1 meter limit, so we actually shuffle the stacks 1 meter to the left, and then we shuffle them all the way back 1 meter to the right, so they move a total of 2 meters. The individual step is typically in a container stack 100 millimeters, and so we induce an error of 100 millimeters on the placement of a container. The side shift on the straddle is 350 millimeters, so that error is easily compensated by the straddle side shift. So a total of in Brisbane, for example, we do a total sweep of the 2 meters, but that's done over 20 steps of 100 millimeters each, and the time between steps really vary. It depends on your pavement design, really. But in Brisbane, for an example's sake, we do it approximately every 2 to 3 weeks. We shuffle 100 millimeters. Lots of great questions coming through now. So the question about the safety of malfunctioning sensors and GPS signals or redundant systems are in place. So no GPS is used in the AutoStrad system. It's no GPS installed on the vehicles. It's radar technology. The algorithm itself is very a lot of care has been put into the algorithm to detect failure of sensors, to detect failure of failure of sensors or of hardware. So it's a very robust algorithm. So really the navigation system is one of the key technologies that enables the automation, and really the key requirement is exactly what this question is getting at: robustness, fault tolerance, and the ability to detect failure in sensors, which of course fail from time to time. A lot of efforts too has been put into the maintenance of the sensors and the ability to calibrate them as easily as possible, and that a technician of minimal training can easily calibrate and prepare the sensors. So a lot of tools have been developed to assist this, and effectively the machine sensors, and they're fairly sophisticated sensors. The tools are so good in a sense that the maintenance staff at Brisbane can effectively maintain and calibrate these sensors without the need for any specialized people to be involved at all. Interesting question about can manual operations and automation, is it an all or nothing system? Are manual operations and automated operations mutually exclusive? Could you run a manual straddle carrier in an automated yard? Well, it depends what this question means. The principle of the safety is that there is a strict separation between all humans and the automated machines. So that includes a human in a manual machine. So it would not be possible to have, say, a manual machine and an automated machine driving in the same general compound. There is possibility to interface between two systems. So this is effectively what's going to happen at Port Botany on the rollout. So Port Botany terminal is a brownfield site, so it's currently a manual straddle operation. And the way the automation will be introduced is that it'll be done at a section at a time. So there'll be a section of the Port Botany terminal that will become fully automated. Effectively, a third of it will become fully automated. And then the border between the automated and the manual machines will gradually move so that the terminal will become fully automated. And the interface between the manual and the automation machines needs to be done in a fairly considered fashion. So there needs to be some degree of design in terms of gates and safety and so on, so that the two cannot, so there's no safety problems there. So grading, the question coming in from Mark Smallridge about the serviceability and the grading requirements of the pavements for the AutoStrad operation. So in Brisbane terminal, Brisbane's a subtropical climate, so there are lots of rainfall in Brisbane, massive thunderstorms, and as a result, the terminal has got rather steep pavements. So in Brisbane, we got up to 2% gradient, 2% gradient of the pavements. And the AutoStrads handled this without absolutely any problem. The only issue with these, with pavements as steep as that, so when you have a change of gradient where the drains are, some care has to be given about twinning containers and placing containers over the drain. But the system itself has the ability to manage the drains and prevent things like twinning, for example, across drains, or twin forming across drains. Serviceability of the pavement. So the pavements themselves, as I've talked about with this stack shuffle feature, with the pavements are maintained to a high degree of standard because we're always moving the roads, we're always moving the stacks. If there is a need to service the pavements, we've developed an access control system which effectively allows an operator to section off a part of the terminal through some safety rated beams so that we of course ensure this separation between humans and machines, and we can section off that part of the terminal for a short period of time or for a long period of time, and so in the case of pavement serviceability, it can be for a long period of time, and when it's sectioned off, the engineers and the people who have been charged with that job have got the ability to work as long as they need to in that area, while the rest of the operation runs relatively unaffected around them. So a few questions about costs coming in, AutoStrads versus manual strads. So there is a modest difference in the cost between an AutoStrad and a manual strad, and we'll be happy to provide in detail what they will be if you get in contact with us after this presentation. However, just point out that the payback, I mean, obviously it depends on your current cost of production, but the payback that we've seen realised in Australia is significant. I'll just point out that Patrick themselves have estimated $50 million per year saving with the introduction of AutoStrads into Sydney, We've seen certainly in Brisbane between $30 to $40 Australian dollars per box saving. So that's, that's up to €30 at the current exchange rate, €30 per box saving. Obviously, that will depend though on a case-by-case basis. So a question coming through on the estimate of time to roll out for a fleet of 30 between official go and a full implementation. So typically the longest period of time is the actual construction of the machines, and that obviously depends on the busyness of the factory. But typically, just to give you some example, typically for a large fleet of 30 machines, the typical construction time might be to 10 to 12 months. So that's typically the longest period of time that's required. So then there is some commissioning time of the machine. So once the machines are built in the factory and depending if they're shipped, knocked down or fully erected, they need to be commissioned to a high degree of standard at the terminal, which depending on the fleet size, can take a couple of months. But typically that's the longest I guess the rate determining factor. The infrastructure, as I pointed out, is minimal. So in terms of what's required, so we need obviously some fences. We need, depending on the layout, you may need some truck rigs, which takes some time to construct. But generally, it's just fences and some radar beacons, which, as I mentioned, are completely passive devices and powered, and that are mounted on poles. So the civil, depending on the terminal, the civil work is generally minimal. So yeah, the main rate determining factor, I guess, is the construction of the machines. So looking at that and the commissioning, you'd be looking at probably between 12 to 18 months for a rollout from placement of order to a go live. So a lot of questions coming in about maintenance and I guess, yeah, the key thing that we've seen in Brisbane, the maintenance of the maintenance costs for the AutoStrad are less. We've realised are less than the manual straddle terminal, and the reasons really, the maintenance for the AutoStrad becomes a lot more predictable. There's very little to no collisions, so the maintenance due to collision damage, which you have with manual straddle carriers, becomes virtually non-existent for an AutoStrad terminal. The nuisance maintenance, the guys ringing up an hour before shift ends and saying, oh, there's a problem with the air conditioning, of course that goes out the window with an AutoStrad terminal. So the maintenance, there's a common misconception that the automated machines are expensive to maintain. They're not. They're actually cheaper to maintain than the manual machines. I can provide some further figures about the maintenance. If people are interested, please just email me through. A question about the truck exchange from Isaac. The driver is required So the question is, at the exchange gate, it was mentioned that the final move was managed by a human remote control. Does this allow the truck driver to stay in the cab, or is the driver required to exit? Yeah, the answer again is that we always want to maintain this separation between the AutoStrads and the human, any human being. And so in this sense, we always insist that the driver exits the cab so that they are not in the same vicinity as an AutoStrad. So yeah, so we insist that the driver exits, and we need a safe mechanism to ensure that they've exited. Patrick had put in a number of methods and procedures in place to ensure that the drivers exit and that they cannot re-enter their cabs while they are being handled by an automated machine. I think this was we've run out of the time. It's now we've come to the conclusion of our webinar. We thank you very much for participating wherever you are right around the world, and we wish you a pleasant evening or a pleasant day or a pleasant morning depending where you are, and goodbye and all the best. Thank you.